Hello, everyone, and welcome back to the Tony Livins podcast. I'm Tony Livins. In the last episode, we explored large language models and how systems like ChatGPT generate human like text. We learned that these models don't actually understand human language in the way humans do. Instead, they learn patterns from enormous amounts of text and predict what comes next. But today, I want to answer a different question. Why did AI suddenly become so much better? For, for years, researchers were making progress, but around 2017, something changed. Not gradually, almost overnight. Suddenly, AI became dramatically more capable. Translation improved, writing improved, image generation accelerated, voice recognition became better than ever. Eventually, we reach systems like ChatGPT. So, what happened? The answer begins with one research paper, a paper called Attention is All You Need. At first glance, it doesn't sound particularly exciting, but many researchers now consider it one of the most influential papers in the history of artificial intelligence because it introduced something called the transformer architecture. And today, almost every major language model is built on that idea. Before transformers existed, AI used different methods to process language. One of the most common approaches was something called a recurrent neural network or an RNN. The basic idea was simple: read one word, remember it, move to the next word, then the next. Almost like reading a book from beginning to end. That worked reasonably well, but it had a problem. Imagine reading a sentence that begins: The student who graduated from university after years of studying artificial intelligence and data science finally accepted. When you reach the last word, you need to remember information from the very beginning. Humans can usually do that. Older AI systems struggled. The longer the sentence became, the harder it became to remember earlier information. This became known as the long range dependency problem. Then came the transformer. Instead of reading language one word at a time, it looks at the entire sentence simultaneously. Think about that for a moment. Instead of walking through the sentence step by step, the transformers see the bigger picture. It can examine relationships between words no matter where they appear. That's a huge advantage. This is where we meet one of the most important concepts in modern AI: attention. Attention simply means deciding what information matters most. Humans do this naturally. If someone asks who invented the telephone, your brain immediately focuses on the important words. You ignore unnecessary details. You concentrate on meaning. Transformers do something similar mathematically. Every word asks, which other words should I pay attention to? Some words become highly important, others become less important. This process is called self-attention, and it completely transformed AI. Imagine reading this sentence. Tony submitted his PhD proposal because he wanted to continue researching artificial intelligence. Who does the word he refer to? Humans answer immediately. The transformer also learns to connect those relationships, not because it understands Tony, but because attention identifies which earlier words matter. This dramatically improves language understanding. Another huge advantage of transformers is speed. Older systems processed words one after another. Transformers processed many words in a parallel. Imagine one worker reading every page of a book. Now imagine 1,000 workers reading different pages simultaneously. Which finishes first? That's why transformer models became dramatically faster to train, and when combined with modern GPUs, progress exploded. Now let's talk something called embeddings. They sound technical, but the idea is fascinating. The transformer doesn't store words like a dictionary. Instead, it converts words into mathematical representations. Words with similar meaning end up close together inside something called vector space. For example, doctor, nurse, hospital, medicine. These words become mathematically related, not because someone manually programmed them, but because the model discovered those relationships during training. That's one reason modern AI can answer questions so naturally. It has learned relationships, not definitions. Now, here's something that often surprises people. Transformers aren't only used for language, they are also used in image generation, video generation, speech recognition, protein folding, scientific discovery, even robotics. The architecture became so flexible that researchers began applying it almost everywhere, and it kept producing impressive results. But despite all of this success, transformers still have limitations. They don't think, they don't reason like humans, they don't possess common sense in the way we do. Sometimes they produce brilliant answers, other times they confidently produce completely incorrect information. Because attention improves prediction, it creates consciousness. And that's an important distinction. The more convincing AI becomes, the easier it is to assume understanding. But impressive output isn't proof of awareness, it's proof of remarkable engineering. Let's step back for a moment. Why does all of this matter? Because almost every modern AI system you're using today depends on transformers. When you use ChatGPT, when Google translates languages, when it generates images, when it summarizes documents, behind many of those systems you will find transformer technology. Understanding transformer means understanding the foundation of today's AI revolution. Now here's something worth thinking about. Every major technological revolution begins with one simple idea: the internet connected computers, the smartphone connected people, the transformer connected information in a completely new way. Sometimes history changes because someone asks a better question. In 2007, researchers asked, what if language doesn't need to be processed one word at a time? That single question reshaped artificial intelligence. And maybe there's a lesson there. Innovation isn't always about making something bigger. Sometimes it's about seeing the problem differently, looking at old ideas through a new lens. That's true in AI, it's true in science, and it's true in life. As artificial intelligence continues evolving, we'll see larger models, faster systems, better reasoning, better planning, more capable assistants. But underneath many of those future breakthroughs, the transformer architecture will remain one of the defining moments in AI history. Thank you for listening to the episode 11 of the Tony Levins podcast. I hope today's conversation helped you understand why transformers became one of the most important breakthroughs in artificial intelligence. I'll see you in episode 12. Take care.